Have you ever looked up at the night sky and wondered what's really out there? For centuries, we've relied on human eyes, and then telescopes, to map the cosmos. But what if I told you we've hit a wall? A limit not of technology, but of our own human capacity. We are on the verge of an astronomical revolution, but it's not being led by bigger telescopes or more astronauts. It's being led by artificial intelligence. The idea of AI in science isn't brand new. For decades, we've used algorithms to crunch numbers and help us make sense of complex data. But we're not just talking about fancy calculators anymore. The rise of large language models, the same kind of AI that powers things like ChatGPT, is completely changing the game. This isn't just about speeding up calculations. It's about fundamentally altering how we do science itself. The question is no longer if AI can help. The real question is, can AI become the scientist? Can it formulate hypotheses, design experiments, and make discoveries all on its own? It's a thought that's both exciting and a little unnerving. Are we about to witness the dawn of the AI astronomer? To understand why this is happening now, we need to look at the sheer scale of modern astronomy. Let's talk about the Euclid mission. This incredible space telescope is on a mission to map the dark universe. It's creating the largest, most accurate 3D map of the cosmos ever produced. Sounds amazing, right? But here's the catch. The amount of data it's sending back is staggering. It's a data tsunami. Just to put this into perspective, Euclid takes 4 images every 75 minutes. Each image is a gigantic mosaic, 600 megapixels in size. Over its planned 6-year mission, it will observe about a third of the sky. The final data archive is expected to be hundreds of petabytes. If you tried to download that on a typical home internet connection, it would take you literally thousands of years. Let's zoom in on just a tiny fraction of that data. The Euclid Consortium recently released some of its first images. One of them, a stunning view of the Perseus galaxy cluster, is just one single observation. It covers an area of the sky about the size of a full moon. Within that single frame, astronomers identified 100,000 galaxies. Think about that. 100,000 galaxies in one picture. Do the math. If one tiny patch has 100,000 galaxies, the full survey could contain billions upon billions of them. And that's just the galaxies. Euclid will also observe countless individual stars, nebulae, and other cosmic objects. We're talking about a catalogue of light sources that will be almost impossible to comprehend. This is where we hit the human limit. No team of astronomers, no matter how large or dedicated, could ever manually sift through this ocean of data. Imagine trying to find a specific grain of sand on all the beaches of the world. That's the scale of the challenge we're facing. We have built a machine that can see more of the universe than we can possibly process. So, how do we find the needles in this cosmic haystack? How do we spot the rare, fascinating phenomena that could unlock the secrets of the universe? This is where AI steps in, not as a helper, but as a necessity. Let's take a specific example. Einstein rings. These are incredible, rare phenomena that occur when the light from a distant galaxy is bent and magnified by the gravity of a closer object, like another galaxy or a cluster of galaxies. They appear as beautiful, near-perfect rings of light. Albert Einstein's theory of general relativity predicted them, and finding them is a huge deal. They allow us to study dark matter and the expansion of the universe. But Einstein rings are incredibly rare and hard to spot. They can be faint, distorted, or hidden amongst thousands of other bright objects. A human astronomer could spend their entire career searching through images and only find a handful, if they're lucky. It's a tedious, painstaking process that relies on a trained eye and a lot of patience. In the past, citizen science projects like the Galaxy Zoo have been amazing. They've enlisted volunteers to help classify galaxies, and it's been a huge success. But even the power of the crowd has its limits when faced with the Euclid data deluge. We would need a citizen science project with billions of participants just to keep up. This is the perfect job for AI. We can train a neural network by showing it thousands of examples of what an Einstein ring looks like and what it doesn't look like. We teach it to recognize the subtle patterns, the specific curvature, the unique light signature. We can feed it simulated data, real data from older telescopes, and every example we can find. Once trained, this AI can scan through Euclid's images at a speed no human could ever match. It can analyze millions of candidate objects in a matter of hours, flagging the most promising ones for human astronomers to review. It won't get tired, it won't get distracted, and its eye for detail can be even sharper than ours. In fact, this is already happening. Researchers are developing and deploying AI models specifically designed to hunt for these gravitational lenses in large sky surveys, and they're already finding thousands of candidates that would have been missed by human eyes. The AI isn't just faster, it's expanding the very scope of what's possible. It's turning a near impossible task into a routine scientific process. But the story doesn't end with just finding things we already know about. The most exciting prospect of AI in astronomy is its potential for a new kind of discovery, the unknown unknowns. These are the phenomena that we haven't even thought to look for. Things so strange and unexpected that they don't fit into any of our current theories. A human scientist is often guided by their existing knowledge and biases. We look for things that confirm or challenge our current understanding. But a well-designed AI can be programmed to look for anomalies, anything that doesn't fit the established pattern. It can sift through the data and flag objects that are just weird. Imagine an AI that analyzes the light curves of millions of stars and finds one that's behaving in a way that no known physical process can explain. Or an AI that maps the distribution of galaxies and finds a structure so vast and unusual that it challenges our cosmological models. These are the kinds of discoveries that lead to scientific breakthroughs, to Nobel Prizes, and to a completely new understanding of the universe. The AI becomes a partner in discovery. It does the heavy lifting, the impossibly large-scale pattern recognition, and then presents the most interesting puzzles to its human collaborators. The astronomer's role then shifts from being a data miner to a creative problem solver, a detective trying to make sense of the cosmic clues that the AI has uncovered. This collaboration is the future of astronomy. We're moving from a science limited by our ability to observe to a science limited by our ability to comprehend. The data is here, but the insight is hidden within it. AI is the key that will unlock it. So, have we hit a limit in astronomy? Yes, we've hit a human limit. We've reached the point where our brains, as powerful as they are simply no longer a match for the scale of the universe we are now able to observe. But this isn't an end. It's a new beginning. It's the moment we hand the telescope's eyepiece, figuratively speaking, over to our new AI partners. The age of the solo astronomer, painstakingly examining photographic plates, is giving way to an era of human AI teams, exploring a digital cosmos of almost infinite size. The next great discoveries might not come from a lone genius staring through a telescope, but from an algorithm that spots something no human ever could. And that is an incredibly exciting future to look forward to. Thanks so much for watching. The universe is getting bigger and stranger and more wonderful with every image we take. If you're as excited about these cosmic mysteries as I am, don't forget to hit that like button and subscribe for more deep dives into the future of science and exploration. See you next time.